So in this video, I'm going to introduce you to the concept of lists and templates. Now, I'm pretty sure you have some idea, conceptually at least, of what a list is, and I'm just going to show you how they work in C# programs. So let's imagine that we want to make a list of something rather than an array. Now, remember, arrays are fixed in size. They cannot grow and shrink. Lists can. That's the big advantage of a list over an array. So let's say that we wanted to create a list. We just start off with the word list, and then we have to say what we want a list of. And this is where the templates come in. You're going to see something like this. You're going to see a type in between a greater than sign and a less than sign. So kind of sandwiched in between the two symbols like that, you're going to have the type of thing that you want to create. So we're saying that we are declaring a list of integers, and let's call it lights, because where we're going to use lists first is in the Simon game. So we're going to say we're going to creating a list of integers called lights. And what this has done is it's declared a variable that can reference a list of integers. However, we haven't created that variable yet. And that object that we think we're looking at right now doesn't get created until we use the new operator. So let's go on and add more to this so that we actually create the thing that our variable is referencing. So let's remove that semicolon and put in an equal sign. So we're going to assign whatever we create on the right is going to get assigned to the left. We're going to create a new list, right? And then what is our list of? It's of integers. And then we just need our function brackets on the end. So I know this is like a big mess right here, but the way to read that is we are declaring a list of integers called lights and setting it equal to a new list of integers, right? So now we've actually created a list here and assigned it to that variable. If we had just gone back to that little bit there and then tried to use lights for something, tried to put something in it, it would say null pointer exceptions. Until we actually use the new keyword, there's no object attached to this thing, and this thing is null. So there we go. Let's put our stuff back. So there's our new list of integers. And now we can do stuff to this list. Like let's say in our code here, we could have, we could test if lights has anything in it. You know, we could say if lights.count equals 0, then say the list is empty, right? Or we could put stuff in the list. Like let's say we've got red defined somewhere as an integer. We could put an integer into our list. It would get stuck at the end. And maybe at the end of the game we want to clear stuff out of the list. So you can see that when you just use a list like this, not only can you create a list of any type you want, you also get all these functions, right? So we get lots of code reuse here, right? Why go create a list class when we've got one built in already? So there we go. Let's go take a look at, let's go just pop over to the list documentation in MSDN in Microsoft here real fast. So here, where's my, damn it. Okay, here we go. Let's pop over to MSDN and look in the documentation for the list. So here's our documentation for the list template. So a list of type T, right? So where T could be anything we want. We even have a list of lists if we want. So you can see all the stuff that that this thing inherits. You can see what library this thing is in. So you might have to put in using system.collections.generic. I don't know if that's imported for us by default. And then we can see all the functions that are in that object. So we can see what how much memory has been allocated for the list, how many things are in it. We can put things in the list. We can do all of this stuff. We can search the list. We can clear it out. We can check to see if it contains a certain element. There's even something in here about reversing the list, right? I'll find the last index of an item, right? There's all sorts of stuff in this list, and so that's why we should use this stuff rather than trying to manage our own, try to write our own, right? And just as a side note, back when I was in school, this is what my evil professors made me do, was actually go write all this stuff. So that's how I got lots of practice. But you don't have to. It's been all written for you, and it's now in the collections, the generic.collections library. There it is, collections.generic. Okay, so let's pop back to that slide that I was going to show you here. So what is the advantage of a list over an array, we've already talked about that. Lists can grow and shrink in size. If you're writing a game where there's bullets constantly being created and destroyed and monsters being created and destroyed, you're going to want to put them in a list. An array would be a bad choice for that. So why do we still use arrays? And I'll show you that in a second. In the computer's memory, when you have a list, it's basically organized as a bunch of blocks. Every block contains something in the list and then a reference to the next block. So those references all chain together in memory to form your list. Now the problem is you can't just, if you want to pop down to the fourth thing in the list, well, you can't do that. You've got to traverse the whole list. You have to go on this treasure hunt from here to here to here to here, and that takes time. So going through a list searching for things imposes a penalty because you have to go on this scavenger hunt through the computer's memory to find what you're looking for. Now, an array is very different. An array is a block of objects in memory that are all right next to each other and they have the same size. So it is very easy to jump to the fourth thing in the array just by multiplying 4 times the size of however big these things are, right? So it is very easy to jump into arrays. Arrays are very good for things like lookup tables that aren't going to change in size. So arrays have the advantage of speed over lists, but lists have the advantage of flexibility. And most of the time, it's negligible, and you're just going to want to use a list. So there you go. That is how lists work. That is why lists are good, and that's why we're going to use them in Simon. And if you have any questions about that, you can either ask me or pop over to msdn.microsoft.com and search the documentation here for lists and go through all that documentation that I just showed you. So if you have any questions, just ask.